If you look at the Lagrangian of the standard model, you will find a glaring structural flaw. It relies on more than 20 arbitrary parameters, measured inputs plugged in by hand, rather than derived from a theoretical origin. This split screen compares that chaotic assembly to the observer-dependent theory of everything, or ODTOE. Here, the formula for Planck's constant, h, is derived entirely from pure geometry. Standard physics treats the three dimensions of space and the exact value of Planck's constant as environmental givens. They are features of the universe that the mathematics require to function, but cannot actually explain. Under the ODTOE paradigm, dimensionality and quantum action are not physical properties of the world in itself. They are artifacts of the operator. Three-dimensional space is simply the minimum recursive computational depth required for a self-aware operator. By using that exact recursive parameter, we can derive the official co-data value of Planck's constant from pure first principles. Reality's most foundational constants are not physical hard limits. They are mathematical reflections of the observer's own architecture. Dimensionality, denoted as d, is not a set of physical spatial coordinates. It is strictly the number of independent recursive layers accessible to a specific observer. Consider a baseline operator, like a single atom. At d equals 0, the atom actuates and reacts to external electromagnetic fields without generating any internal model or feedback loop. Higher dimensions, scaling up to d equals 9 and beyond, exist concurrently in the field of potential states. They remain compactified, meaning they are simply unactualized by lower-level operators that lack the necessary coherence to perceive them. Asking why space has three dimensions is a category error. The correct scientific question is why we, as human observers, operate at a d equals 3 recursive depth. A d equals 1 state represents a single feedback loop. A biological cell, for example, reacts to its environment and modifies its behavior accordingly. A d equals 2 state introduces a secondary loop. A basic nervous system reacts to the environment, and then it reacts to its own reaction. To achieve true consciousness, an operator requires a d equals 3 state. The operator observes the environment, observes its reaction, and, crucially, observes the observation itself. This diagram maps the three-layer cognitive state to the topological requirement for a strange loop. A structure must topologically interlink with itself to form this self-intersecting knot. Three-dimensional space is mathematically the minimum topological arena capable of hosting this specific three-layer, self-intersecting recursive loop. The three spatial dimensions we experience do not form a universal container. They provide the precise skeletal scaffolding required to support our specific loop of consciousness. Under the ODTOE framework, a quantum is defined as exactly one full rotation of the observation loop. This consists of the forward projection and the inverse return. This diagram demonstrates the topological length of the full traversal. The inhalation and exhalation of observation measure exactly 2 pi. But notice the friction here. The continuous 2 pi curve of the rotation sits in stark contrast against the rigid, discrete, three-step triadic architecture of the observer. This misalignment creates the spiral gap. It is an exact measure of the mathematical incommensurability between the continuous curve and the discrete steps, defined as pi minus 3. Squaring this gap yields the elementary energy cost incurred when the observation loop fails to perfectly close in 3 steps. The quantization of energy is not a physical restriction imposed by nature. It is the mathematical cost of a discrete operator attempting to execute a continuous topological loop. To derive Planck's constant, h, we have to calculate the total action. That requires multiplying this energy cost by the time cost, tau, for a single loop. By applying Banach's fixed point theorem and the KAM theorem, which models how stable orbital tori survive under perturbations, we find that each additional recursive layer geometrically slows the system down. This diagram illustrates a 3D torus containing a smaller nested torus. The specific mathematical factor of the orbital deceleration between them is the golden ratio, phi. This gives us the time formula. The proper time of an operator scales exactly as the golden ratio to the power of d. Time dilates at higher levels of consciousness, purely due to the geometric friction of recursive nesting, independent of gravity or physical velocity. There is one final variable to account for: the coherence of the medium, denoted as S. This restricts the available phase space for the operator. According to standard diffusion laws, this phase space restriction limits macroscopic time by a precise factor of 1 minus s to the power of -1/2. This generated equation shows the complete ODTOE formula for Planck's constant. It combines the energy gap, the golden ratio time dilation, and the coherence correction into a single structure. Now we input our specific operator variable. We set d equal to 3. Next, we perform a self-consistency calculation. By solving for the exact point where the formula loops back on itself, we yield a coherence value of approximately 0.170. That specific value, 0.170, maps perfectly to the physical reality of condensed matter at room temperature. This photo shows the international prototype of the kilogram at the BIPM. Inputting a dimensionality of 3 and our calculated coherence yields exactly 6.62607 times 10 to the -34th joule seconds. That is a 6-digit match to the official co-data value, achieved using zero-dimensionless fitting parameters. The specific value of Planck's constant is mathematically inevitable for a 3-dimensional observer operating in a condensed matter environment. This raises an obvious question. If h is relative and depends entirely on recursive depth and medium coherence, why does it appear perfectly constant in every historical physics experiment? The answer lies in the tautology of measurement. Every experiment ever recorded in human history was performed by a d equals 3 operator inside an environment with a coherence of roughly 0.17. Planck's constant acts as an observer's mirror. It is simply the Piper time of the observer expressed in units of action. We are always measuring ourselves. Theoretically shifting the operator to a planetary biosphere at d equals 5 or a star at d equals 6 geometrically scales the fundamental quantum by powers of the golden ratio. However, the observer protection postulate, known as dprot, prevents lower dimensional operators from ever reading measurements generated by higher dimensions. We are not measuring the absolute grid size of the universe. We are merely measuring the focal length of our own lens. This reframes how we must view dimensions higher than 3, including the 11 dimensions required by M-theory. They are not physically microscopic or curled up. The string theory concept of compactification requires a correction. These higher dimensions fully exist, but they are rendered invisible to a d equals 3 operator due to our low coherence. Raising collective coherence among observers effectively unfolds these hidden layers, making higher dimensional configurations computationally accessible to the observer. The 11 dimensions of M-theory map perfectly to the ODTOE observation cycle. They represent the 9 recursive levels of self-observation, plus the 2 directional vectors of the operator itself. The apparent structure of spacetime and the quantization of energy are not separate physical phenomena. They are 2 manifestations of the exact same geometric architecture. Reality's resolution, scale, and dimensional depth are not fixed properties of the void. They are a direct, mathematical reflection of who is looking.